I welcome you all to this tutorial session on week 5. This tutorial will be taken up by me, Mohammad Owais Khan, the Prime Minister Research Fellow from the Electrical Engineering Department. In this tutorial, we are going to discuss several questions and concepts which you have learned in your NPTEL lecture on the week 5. So before I start, I would like to welcome you all to this. Now, what we are going to discuss here is I hope the screen is visible to you. So, basically, what I am going to discuss here, we will solve some questions. I think, okay, this is correct. So, we are going to discuss about the sag and tension calculation, okay, and why they in the and also I hope I'm audible to you all. Okay. If not, then you can write in the chat box. Okay. And we are going to discuss how we can calculate, the sag and tension. And we also going to discuss about the effect of wind and ice on these sag and uh, tension calculation. So basically, what happened here is that generally, whenever a transmission line is connected between two poles, so it get instead of connected like this, it gets sagged due to the due to its own weight and the gravity action. So basically, what we do here, we do calculation of how much tension is there, how much sag can be allowed, because sometimes if we allow higher sag, then it may touch to the ground or close to the ground. So basically, we all do these calculations, and I hope you have gone through the calculation how we are going to affect how in the this sag calculation be done, and I will write it down various formulas here for sag. Sag is calculated, which is maximum at D is equal to L squared del upon 8F, where del is uh, the density of the conductor material, which is also a constant, because for any given material the density remains constant, and F is the stress, which is corresponding to the tension T. Okay, and A is the area of the cross section. So basically, these are the this is the formula to calculate the tension. Sorry, sag. Okay, so basically, what happens here is that we design our overhead transmission line for the worst case. Like, what is the worst case can be possible? So based on that, we design our transmission line. So what happened here is that in some part, whenever there is a transmission line is designed in any geographical area, the wind is also an important factor. So what happened here is that effect of wind must be considered in the transmission line design. Like generally, weight of the conductor is pointed downward. Okay, this is the one effect. Another is the wind. Wind generally blows like this, so it is a horizontal effect. So it may drag the transmission line toward this. So it is due to air. Okay, but there is another effect which is the ice. What happens to the ice if ice gets, you know, placed over it, like, you know, so it will have an effect in a downward direction. Okay, like here. So another, this is of ice. So basically, these are the two vectors, and their net loading will be a resultant vector W net. Okay, that W net is calculated by W plus Wi whole square plus Wa square. It is a basic, formula to calculate the resultant or total loading. But in a vertical direction, the loading is in vertical direction, the loading is due to weight of the conductor and the ice. Okay, so we will solve some various questions regarding this, how we can, how we can solve questions. I hope you have gone through it, their derivations in the lecture, because it is not quite lo- logical to drive again those things which you have already gone through. So basically what I will do here, I will solve some questions, and which will help in the better understanding of these. Okay, so first question, because in this type of concept they are better understood by solving the questions. Okay, so let's let me solve one question. An overhead line, an overhead line has the following data. Okay, its span length is 160 meter. Conductor diameter is 0.95 centimeter. Weight per unit length of conductor, it is 0.65 kilogram per meter. Ultimate stress means maximum stress is 4 to 5 kilogram per centimeter square. Here, wind pressure is given, so we have to integrate wind effect also. Okay, which is 40 kilogram per meter square of projected area, of projected area. Safety factor, safety factor is 5. So what we have to calculate? We have to calculate the sag. Calculate the sag. Basically, we have to calculate the sag. Now, what happens here is that now I will explain how we are going to solve it. So, solution. Okay. What is the safety factor? It is 5. So, the working stress will be, सेफ्टी फैक्टर को हम इंटीग्रेट करेंगे, को कंसीडर करते हुए कितना हो जाएगा सेफ्टी फैक्टर को करते हुए डिवाइडेड बाई 5। वर्किंग स्ट्रेस जो है, जो अलाउेबल स्ट्रेस है हमारा, इतना हो जाएगा, विच इज इक्वल टू 850 किलोग्राम पर सेंटीमीटर स्क्वायर. So this is the our working stress. Now, first we will calculate area of the cross section. What is the area of the cross section? It is equal to pi by 4 into d square, because diameter is given. So pi by 4 into, what is d? D is 0.95. 0.95 whole square is equal to, so इसको अगर हम solve करें, then it will come out to be, just a second, let me solve it. Okay, so it will come out to be 0.7084 centimeter square. Now, wind pressure is given of a projected area. So per unit length में conductor wind pressure क्या होगा? So wind pressure per unit length, per unit length, what it will be? It will be 40 into multiplied by the diameter, which is 0.95 into 10 raised to the power minus 2, because we have to convert into meter. So based on that, it comes out to be 0.38 kilogram per centimeter. And weight per unit length of the conductor कितना है? Which is already given. Weight per unit length of the conductor, it is 0.65 kilogram per meter. Okay, so based on that, what it will be, we have to calculate the weight, total effective weight. And we know that कि जो weight of the conductor होता है, it is downward, let's say it is WC, and weight effect due to air, I just told you, it is in a horizontal direction, let's say this is air. So resultant weight कितना होगा? Total effective weight, how much? It is equal to WC square plus W air whole square. Okay, based on that. So what is WC, which is the conductor? It is 0.65 whole square plus 0.38 whole square. So it will come out to be 0.65 and 0.65, how much it is? 0.4225 plus 0.144. So it will come out to be like 0.5669. So if we solve it, let me calculate it for you. Just a second. Under root 0.5669. So it will come out to be 0.7529 kilogram per meter. So this is the what? A total effective weight. Now working tension, what it will be? Working tension. Working tension, it will be 850, which is the working stress, and if we multiply it by the total effective weight, which is 0.75, actually, just a second, no, sorry, point tension we have to calculate the stress into area, we just calculated the area over there. Okay, 0.7084, Okay, this is the area we are going to take. So based on that, what its value will be? Let me calculate it. So 850 into 0.7084. So it will come out to be 602.14 kilogram. Okay. Oh, so now, as we know in the formula of sag, what is the sag formula? I just told you 8L square upon 8C. Here C is this much. Okay. So C, what we call it here, it's a distance, and L is the span length. So basically we have to calculate the C. So we know the formula to calculate the C. T is equal to W into C. You should have gone through the calculation where what is the W? W is the, what is W? So W is the effective weight and T is the tension, which is we have just calculated working tension. Okay, so based on that, we are going to calculate the C. C is T upon W. What is T? 602.14 divided by W, which is 0.7529. Okay, 7529. So based on that, let me calculate the C value. It is 602.14 divided by 0.7529. It is comes out to be 100 in meters. Okay. Now C we have calculated. L we know, which is 160. 160. How much it is? 160 meters. So based on that, we are going to calculate the sag. Sag is L square upon 8C. What is L? 160 into 160 divided by 8 into C. What is C? 800. So let me calculate it for you. 160 into 160 divided by 800 divided by 8. So it comes out to be 4 meter. Okay. So the sag value in this question is 4 meter. So I hope so you have understood how we are going to calculate the sag whenever there is a wind pressure. Okay, I hope this is quite clear to you. Now we are going to solve another question, question number 2. In this question it is given a transmission line conductor having a diameter of 19.5 mm, weights 0.85 kilogram per meter. The span is 275 meter. Now, there is wind pressure also. The wind pressure is 39 kilogram per meter square of the projected area. Okay, with ice coating, with ice coating of 13 mm. Okay, so basically the ice coating क्या है उस कंडक्टर पे 13 mm की है. The ultimate strength, the ultimate strength of the conductor कितनी दी हुई है is 8000 kg. Now what we have to calculate the maximum sag. Okay, if the factor of safety is 2 and ice weighs 910 kg per meter cube. Okay, so basically we have to calculate this. So what is given here? एक ट्रांसमिशन लाइन दी गई है जिसका स्पैन है 19.5, डाया है 19.5 mm और स्पैन है 275 मीटर्स का. तो लेट मी राइट डाउन द ओवरऑल. तो अब हमको क्या है, ये तो कंडक्टर है, इसका डाया 2r के बराबर है. अब इसमें क्या है, आइस की कोटिंग्स और है चारों तरफ. दिस इज आइस कोटिंग. ठीक है, ये क्या है, आइस की कोटिंग. तो ओवरऑल डाया ऑफ द कंडक्टर विल गेट्स इंक्रीज्ड. So basically, the overall dia of conductor कितना हो जाएगा? एक तो 1.95 सेंटीमीटर अपना है, प्लस कोटिंग कितने की है, इट इज ऑफ 13 mm. तो डाया इसको डबल हो जाएगा क्योंकि कोटिंग ये 13 mm है, तो डाया में ऐड करने के लिए 2 टाइम्स मल्टीप्लाई कर देंगे तो 2.6 सेंटीमीटर, क्योंकि वी आर टॉकिंग इन टर्म्स ऑफ सेंटीमीटर. तो इट विल कम आउट टू बी 4.55 सेंटीमीटर. सो ओवरऑल डाया जो है हमारी कंडक्टर का विद एन आइस कोटिंग इज दिस मच. नाउ द प्रोजेक्टेड एरिया पर मीटर लेंथ ऑफ द कंडक्टर विल बी. सो अब फर्स्ट सेकेंड थिंग हमें निकालनी है, प्रोजेक्टेड एरिया, एरिया पर मीटर लेंथ ऑफ द कंडक्टर. ओके, so it will be 4.55 into 10 raised to the power multiplied by 2 minus 2. Okay, so based on this, the projected area will be like this. Okay, now wind load per meter of the length निकालना है हमको. सबसे बड़ी बात, सबसे मेन चीज है लोड wind load पर मीटर ऑफ द लेंथ. हमें विंड का प्रेशर कितना दिया हुआ है, 39 पर किलोग्राम पर मीटर स्क्वायर में. इसको अगर हम मल्टीप्लाई कर दें 4.55 से, ओके, so basically it will come out to be 1.77 kilogram per meter. Okay, wind load per meter of the length हमें निकल के आ जाएगी. You can multiply it by using a calculator. It will come out to be this. Now, the thing here is that we have to calculate the area of the section of ice. Area of section of ice. अब क्या है कि let's say this is R, let's say this is T. तो इसका एरिया निकालना है. तो इसका एरिया कैसे निकलेगा? R प्लस T1 का होल स्क्वायर माइनस पाई आर स्क्वायर. एक्सटर्नल टोटल में से हम इंटरनल अगर हटा दें तो वी विल गेट द एरिया अबाउट this ice. So basically it will pi r plus t whole square minus r square. What is r? We have just calculated how much r is there? R plus t. So let me give you what is overall dia. It's 4.55. Let me calculate it for you. What is r plus t? So 4.55 divided by 2 plus 1.3. So it will come out to be just a second, just a second. What is R? Okay. So R here is let's take in mm. Okay. Let's take this calculation in mm. After that we will change into centimeter. So what is R in mm? D is mm in 19.5. So R will be 9.75. If we just multiply it divided by 2. Okay. These are all calculation in mm. Now, now what happened here is that 45.5 divided by 2. Now, what is R? R is 9.5 plus what is T? It is 13. So if we add this, it will come out to be how much? 22.75 square minus this. So by the use of calculator, we can calculate this pi is come out 517.56 minus 9.75 square. It comes out to be 95.06 in mm. Make sure this calculation is being done in the mm. So if we calculate this by the help of calculator into how much 3.14. So if we multiply this whole, it will come out to be 31326.65 mm square. Okay. So this is the area of the section of ice. Okay. Now why are we calculating it? Because we have to calculate the weight of ice in per meter length. It is equal to 1.327, we just calculated, into 10 raised to the power minus 3. Why? Because we are converting it into a meter, into 910. What is 910? It is the weight of ice per meter cube. So based on that, if we calculate it, let me calculate this value 131. We will use it, actually it is 6. If we, you know, 1327 mm square, let me put it in like this. Okay. So this one 1.327 into 910. So the value will come out to be 1.207. Let me give it 8. So it will be round off this much. So the weight of ice is this much. Now we know that ice weight goes work in a downward direction. Same with the conductor weight, but the air weight goes like this. We have calculated the W air. What it is? It is comes out to be 1.77 kilogram per meter. W ice is 1.208 kilogram per meter, and W conductor, what it is? It is how much it is given in the question? It is 0.85. It is 0.85 kilogram per meter. So now if we calculate the resultant, if we calculate the resultant, then what it is will be? The total effective weight. How it will be equal to under root WC plus W ice whole square plus W air whole square. So based on that, we are going to calculate this. What is W ice? W ice is, we just calculate 1.207 plus conductor is 0.85 plus 1.77 whole square. This is effective weight. Let me call it like this. Okay. So let me solve it for you. How it is going to, what's the value these are. So 0.85 plus 1.207. Its square. It comes out to be 4.23 plus 1.77 whole square 3.13. Okay. So if we plus it with 4.23, it will come out to be 7.36. And if we take the square root, the value will become out to be 2.71 kilogram per meter. So this is the effective way after considering, after considering various ice and the air. Now, the working tension, what it will be? The safety factor is given. Safety factor is 2. So the working tension will be equal to 8,000 is the ultimate stress divided by 2, which is equal to 4,000 kilogram. Okay. So this is the working tension. Now after this, we are going to calculate the C. It's a simple formula. Just told you about what is C. C is equal to T divided by W. T is the 4,000, W, which is the effective weight 2.71. So value will be equal to 4,000 divided by 2.71. It will come out to be 1476 meters. Okay. And maximum sag D is equal to L square upon 8C. It is equal to L, the span length. It is equal to 275 into 275 divided by 8 into 1476. Let me calculate it for you. 275 into 275 divided by 8 divided by 1476. So I think it's come out to be 6.33 meters. So this is the maximum sag in the in this question. So I hope you have understood this problem. Okay. So This is how we calculate the sag in any question. Okay. Now we will move on towards other questions like uh, like how we are going to calculate what are the effect of the sag. And so I hope you have understood this concept of sag. Now what we will do here, we will solve some other questions and you have to give me the answer. Okay, just a second. So question number 3. If the span of a transmission line, if the span of a transmission line increases, the sag will first A, increase, B, decrease, C, remain same, and D, independent of span. So write in the chat box the correct answer for me. Okay, what is the correct answer? So write in the chat box the correct answer. Yes. So it is directly proportional to the L square span. So it will increase. Okay, just a second. Let me give you another question, a numerical. Okay. Mhm. Just a second. Let me give it to you. So these are all the questions regarding the SEG. Okay. So one more question, the last question. Then after that we will go no, toward the corona discharge. A transmission line has a span of 300 meter. Okay. If the con- if the conductor weight per unit length is 1.2 kilogram per meter and the horizontal tension, just a second, the tension in the conductor is 4000 4000 kilogram. We have to find the sag. Okay, give me the correct answer in the chat box. It's a simple, very simple question. Just calculate it for me. What is the answer? Okay, we have to use the formula. Which formula is S is equal to WL square upon 80. So using that formula, give me the answer. WL square upon 80. Okay. Anyone? No one. So actually, in this, what we have to do, what is W? W is the weight per unit length, which is 1.2 kilogram. Okay. And L is the span length, which is in 200, 300 meter, which is zero point 0.3, sorry, 300 meter is all given in 300 meters. So it is 300 into 300. Now 8 into T. What is the tension? So tension it is given. So we have to calculate the tension regarding this. So tension is the conductor weight because there is no air. So tension will be dependent upon the conductor weight, which is 4000 into G, which is 9.8. So now based on this, if we calculate it, what will be the value? Let me, the sag will comes out to be, just a second. If we put these things in the perspective, it will come out to be 4000. This is 0.35 meter. Okay. So the sag will be del, which is equal to 0.35 meter. Yes, yes, yes. How are you going to calculate 3.375? No, no, you have taken the weight only, but we have to take horizontal tension in the conductor. Actually, the question is something quite, misleading. They have given the tension. If we take only tension, like this is kilogram per meter square, then we have to remove this. Then 3.375 will be coming. Okay, so let's assume it is given the tension. Okay, so basically we are not going to take the this much. So based on this, it will come out to be 3.375. Okay, because they have given the tension but not in the units are not right. No problem, we will adjust on our own. Okay, so based on this, you have get an idea how we are going to calculate this. So now we will talk about. We have already talked about the corona discharge in the next in the previous lecture, but we will solve some questions here also. And before that, I'm going to discuss a formula, which is a Peterson's formula, and its formula is based basically on the calculation of the corona losses. And last time I've already given this formula, but nevertheless, it is 241 into 10 raised to the power minus 5 f plus 25 divided by delta under root r by d, under root r by d, this under root is small, v p minus vo all square kilowatt per kilometer per phase. So this is the formula to calculate the what it is. It is to calculate the corona discharge. So now the first question regarding this corona discharge is, you can give the answer in the chat box. So because these questions are much more understandable when we solve it through the questions. The effect of corona can be reduced by, first option, reducing the spacing between conductor. B, reducing the conductor size. C, increasing the spacing between conductors. D, increasing the conductor size. Okay, so tell me which of these there are The options are correct. It may be one or more than one. So write in the chat box which of the following options are correct, because there may be an options which are more than one correct. So tell me whether it is A, B, C, D, or A or B, C or D, whatever it is. Write in the chat box. D. Only D. I don't think A correct नहीं है, इसमें multiple corrects हैं. So basically see that also. Someone is saying D and C. D and C means increasing the conductor size, okay, and increasing the spacing between the conductors. So which one? Someone is saying C and D, increasing the conductor size. And दोनों एक ही कह रहे हैं. कोई और other than A, reducing the spacing between the conductor. Okay, let me see it. Anyone else? देखो क्या है, effect of corona can be reduced by, first of all, reducing the conductor size. Okay, increasing the spacing between the conductor or increasing the conductor size or reducing the spacing between. तो हमें इसमें से ये देखना है कि कोरोना का इफेक्ट कैसे हम रिड्यूस कर सकते हैं. ओके, तो हमने एक फॉर्मूला पढ़ा था which is P is directly proportional to R and D. What is R? R is the radii of that conductor and D is the spacing between the conductors. तो हम कोरोना को का इफेक्ट कम कब करेंगे, जब कोरोना लॉसेस जो है रिड्यूस कर देंगे, और दे आर डायरेक्टली प्रोपोर्शनल टू आर बाई डी. तो अगर हम इफ आर को रिड्यूस कर दें, which is the reducing the conductor size, the corona losses will gets reduced. ठीक. D is the spacing. इसको अगर हम increase कर दें, if we increase the spacing, then it will also decreases the corona losses. So basically the C option. So B and C is the correct one, not C and D. Okay. So let me just a second. Now, next question is question number 7. Following effects are caused by corona. First is power loss. Second is production of ozone gas. Third is non-sinusoidal voltage drop. Fourth is reduce the effects of transients caused by surges. So now tell me कि इसमें से कौन सा सही है. There may be more than one correct answer. Okay. Hmm. A and first A and B. First and one, two, three, four options दिए हुए हैं, not A and B. Power losses, okay. So क्या है कि first of all, corona losses क्या करते हैं? They do a power losses. Okay. अब क्या होता है? Whenever there is a corona loss, you see there is a hissing sound. It is due to the production of a ozone gas. Okay. Up current non-sinusoidal voltage drops, they don't generally do these type of specific drops, okay, or reduces the effects of transient caused by surges. This is not the effect. So basically, the correct option is first and second. Okay. So now question number 8. The breakdown, it is a numerical. You have to give me the answer of this. Breakdown strength of air at STP is 3 kV peak per mm. Okay. The breakdown strength the breakdown strength of air in kV RMS at 26 degrees Celsius and 74 centimeter of Hg is first option है 21.25, B 20.58, C 23.71 and D 19.64. So you have to give me the correct answer of this. Okay. So write in the chat box the correct option. इसमें एक फॉर्मूला मैंने बताया था लास्ट टाइम वी हैव टू यूज दैट फॉर्मूला ओके so let me solve it for you. So What is the breakdown strength? So first of all, breakdown strength at STP, standard temperature pressure. What is it given? It is 3 kV peak per mm. So it will be 30 kV peak per centimeter. It's okay. Now we have to convert into an RMS. So basically 30 divided by root 2 kV RMS per centimeter, and you can see it will come out to be 21.21 RMS kV per centimeter. Okay, so what happens here is that okay, now what happens here is that we have to calculate it at the 75 m 74 actually. Just a second. Breakdown strength at 26 degree and 74 mm of Hg. Okay. So basically, we know that air density correction factor. Last time we have del is equal to 3.92 B divided by 273 plus T. So now what we have to do here, we have to calculate what is B. B is the x centimeter of Hg and T is the temperature in degree Celsius. So basically in this question, what we have to do here, we have to calculate it in 26 degree and 74 of Hg. So for that, del come out to be del is equal to 3.92 into 74 divided by 273 plus 26. So calculate this value, and what will be the answer? Let me calculate it for you first of all. 3.92 into 74 divided by how much? 273 plus 26. So if we solve it, it come out to be 0.97. Okay, 0.97. Now 0.97, and we know that breakdown strength is at 300. So breakdown strength, just a second, just a second. Okay, so breakdown strength will be equal to, at a given condition, what it will be, it is equal to 21.213, okay, multiplied by 0.97. So if we calculate it, it comes out to be 20.8 kV RMS per centimeter. Okay, so it's a uh, direct relationship with that. So at any point, at any temp as a standard at any temperature pressure, we have to calculate. First, we have to calculate the delta, which is the air density fraction, and multiply it by the standard. So we will get the answer to this question. So basically, the correct option will be how much? 20.8. Okay. So I think 20 point this much. This will be the correct. Let's say remove this. Okay, so 20.8 will be the correct. Just a second. I hope you understood this question. Yes, yes, yes. Just a second. Let me solve it. Give you another question. Okay. So another question here is yes. So next question here, question number 9. A 132 kV three-phase transmission line has transmission line with 2 centimeter diameter conductors is built so that corona takes place if the line voltage exceeds 21 kV RMS. If the value of potential gradient at STP, at which ionization occurs, can be taken as can be just a second, just a second, can be taken as 30 kV peak per centimeter. Okay, find the spacing between the conductors. Find the spacing between the conductors. Assume irregularity factor 0.98 and air density factor 0.96. Okay, 0.96. Okay, so we have to find the spacing. So solve it for this. Now what happens here is that What is given here? क्या है कि 132 kV ट्रांसमिशन लाइन दी हुई है is built so that the corona takes place if the line voltage exceeds 210 kilowatt per RMS. Okay, listen carefully. If the value of the potential gradient at which ionization occurs can be taken at the 3 kV peak per centimeter peak value, find the spacing find the spacing between the conductor assuming irregularity factor and air density factor. So basically, we should know the formula of disruptive disruptive critical voltage. What it is? VDO G into del into M in MO into R into log D by R. Okay, G is given here. What it is given here? G is 30 kV peak per centimeter. So if we change it into RMS, it will 30 by root 2. Okay. Now del is the air density correction factor, which is given here how much? Point, I think it is 96. 0.96. And the irregularity M. Irregularity factor is given 0.98. Okay. So what we have to do here, we have to calculate the spacing between the conductor, which is D. Okay. Now another thing is that it is given here that voltage gone above the 210 kilowatt RMS. Okay, if the line voltage. So basically, uh, VD, which is critical voltage, is given 230 divided by root 3 kV. Okay, so putting these value, it is 230 divided by root 3 is equal to G. What is G? G is 30 by root 2. Air density factor is given 0.9, 0.96. Irregularity factor is 0.98 into log T. We have to calculate, and R is given here with a diameter is 2 centimeter. So basically it will be R will become 1 centimeter, and we have to put it in, like, let's say this is 1. So if we solve it for this, so log D will come out to be 230 into root 2 divided by, it will all come root 3 into 30 into 0.96 into 0.98. So I will first calculate this for you. Okay, 0.96, 0.98. Okay, yes. Let me first calculate it. Root 3 into 30 into 0.96 into 0.98. So it come out to be 48.88. So 230 into root 2, how much it is? It is 325.26. So it is divided by 48.88, and if we, it comes out to be 6.65, and if we calculate it 6.65, just a second, 6.65 E. I think the correct calculation is correct. Just a second. KV, KV. Okay, yes, it is correct. Okay, yes. So log D will come out to be 6.65. So if we take the inverse, D will come out to be e raised to the power 6.65, which is 772.78 centimeters. Okay, and based on that, if we calculate it, D, it will come out to be, if we divide it by 100, so 7.72 meter. Okay, let me check it for the what is the options. Actually, options are not correct in this. There is something problematic. No problem, but the steps are right. Okay, this is how we are going to solve it. Okay, yeah, okay. If because options are, they are something wrong in the options. Maybe values are left, are changed. Just a second. Okay, okay, yes, no problem. The steps you should take, these are correct. Okay, now next question here is, what is the, let me solve it for you. Hmm. Disruptive critical voltage. Just a second. Let me see it for you. I think. Okay. Yes. 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 That's the problem. It is 210. Okay. Okay. Let me see. Let me calculate it for you again. Yes. 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 It is root 2. Then if we divide it, 48.88. Okay. E raised to the power this. Yes. 4.375. Yes. 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 It is 210. It's not 230. I don't know why I wrote 230. It is 210. 210, and the value will get changed. Okay. That's why I'm considering why it is coming high. So it will be how much? Let me calculate it again for you. 210 into root 2. So it will be 296.98. And if we divide it by 48, just a second, 48.88, so it will come out to be 6.075, and if we take the E, it will come out to be 435. Okay, base, just a second, 6.075, and its value now, this value will get changed. It is how much? 6.075, and this value also gets changed. So it will come out to be 435 approximately. So it will come out 4.35. So basically, the first option will be the correct one. No, no, 210 divided by root 3. Okay, because we have to calculate uh, the and 30 also divided by root 3 root 2, because it is a peak value given. We have to consider the disruptive voltage in a RMS value, which I have discussed in the last time also, because the disruptive critical voltage we have to calculate in the in the RMS value. So that's why 30 divided by root 3 and VL by root 3. Why? Because we calculate line to neutral voltages. Okay, that's why we divided VL by root 3. Hope this is okay. That's why 210 by root 3 is there. Okay, so based on this, it is going to calculate this. Okay, now let me give you another question. Just a second. Okay, another question is here. A three-phase 220 kV, okay, 220 kV trans 50 hertz, 100 kilometer long transmission line. Transmission line consists of zero point 0.8 centimeter radius conductor spaced at 2.5 meter. Okay, calculate the disruptive critical voltage in kV RMS between the lines. Now, taking air temperature कितना 24 degree Celsius, barometric pressure 74.5 centimeter of Hg, and surface irregularity factor 0.94, and dielectric strength, which is G, is 21.1 kV per RMS. Okay, it's a very simple question. You can calculate the disruptive voltage, but here keep in mind we have to calculate between the lines, because in general the voltage we calculate the disruptive is line to neutral. So let me solve it for you for first. So first of all, the formula of this is V d G into del into m naught into r log d by r. So air density, barometric pressure means it is, it is calculated the air the pressure. I think barometric pressure means it's the pressure which you calculate by measuring the height of a mercury. Okay, it's a barometric pressure. I think it's self-explanatory. Air density factor, okay, which is del 3.92 B divided by 273 plus T. What is B here? B means how much centimeter of Hg is there. Okay, I have just already told you. So 3.92 into 74 divided by, it is B is representing the barometer pressure of a surrounding air, but in centimeter of Hg. Okay, 273 plus T. What is T? Is 24. I think 24 it is. Yes, just a second. It is 74.5. So I hope you understood that. We can consider root 3. For what we can consider root 3? Okay, so let me solve it for you. So 3.92 into 74.5 divided by, it's come out to be how much? 273 plus 24.988. Whenever I solve this question, please check the values. Okay, sometime, you know, in all this I mistakenly write wrong values. Okay, yeah, for that we can calculate that. Yes. So air density fraction comes out to be how much? This much. Okay, now dielectric strength. Dielectric strength is given, which is G not, it is 21.1 kV in RMS. So we don't have to change in the any other value. Surface irregularity factor is 0.97. Just a second. Just a second. Okay. Now conductor radius. It is what is given here in the conductor radius. It is 2 centimeter, I think. 0.8 centimeter. Okay. So constructor radius point 8. Okay. 0.8 centimeter. Yes. Point, yeah. Okay, just a second. I am missing that. 0.94. Okay. This is 0.94. Okay. So spacing between the conductors has given 2.5. So it will be 2.5 meters. So it will be 250 centimeter. We will put in the centimeter values. So using these VD0, what is delta? Sorry, first 21.1 into m naught, which is 0.94, and the air density factor we just calculated 0.985 into r 0.85 log d is 250 divided by 0.85. Now calculate this and give me the value. What is the value of this? Okay, comes out to be. I am waiting for your values. क्या वैल्यू आई? टेल मी. No one has solved this. Let me see. Radius is point 0.8. Yes, yes, radius is point 0.8. Oh, just a second. Yes. I know, don't know why I'm writing extra 5. Give me the value. Let me see how many of you are, you know, attending, not just present here. Use your calculator. Okay, someone is saying Lucky Agarwal 89.78. Okay. Anyone else? Sonic Pramanik, have you got any value? Let me calculate myself also first. Let's see what value. Okay. Eighty-nine point. Yes, yes. So the value comes out to be 89.78, somewhere 79. All are okay. KV RMS. Okay. But this value is from line to neutral because the formula is itself designed. So for VLL, it is equal to VDU into root 3. So multiplied by root 3, we will get the correct value. So I think, let me calculate here. So it will be 89.78 into how much? Oh, just a second. 3 into 89.778. Oh, this is wrong. 154. Okay. 154 point 155.7. Sorry, 52. Okay. This is the critical disruptive voltage between the lines. So if we go in the options are given. First option is 89.5 to 90. B is 155 to 155.5. C is 175.2 to 175.7. D is 193.2 193.6. So basically B option will be the correct one. Okay. Okay. Now we will solve another question. Okay, so let me solve, give you another question. Question number, it is 9, 10. This is 10. So another one, 11. Okay, using Peake's formula, using Peake's formula, determine the total corona loss for a hundred three-phase 100 kilometer long transmission line operating at 110 kV, 50 hertz, 50 hertz, and has a conductor size of 1.2 centimeter dia and spacing of 3 meter. Assume the irregularity factor 0.98, air density factor 0.96, and dielectric strength is 21.1 kV RMS per centimeter. Okay, so basically, what we are going to do here, we have to calculate the power loss. Okay, and we have to use the Peterson's formula. Okay, it's a quite long question. So I will give you steps. First, we will calculate the what we are going to calculate. We are going to calculate disruptive critical voltage. Okay, which is VDO. Okay. Then after that, we will use this formula. What formula? 241 into 10 raised to the power minus 5 F plus purchase divided by delta into R by D V phase minus VDO whole square. Okay, and as this is for the three phase, we will multiply it by 3. Okay, so this is the thing here. But this we have to calculate for the total because this formula is for its unit is for kilowatt per kilometer per phase. It is kilowatt per kilometer per phase. But we have to calculate the total. So we will multiply it by 100, which is the length of the this transmission line. So now this it will be the total corona loss. So first we will calculate VDO, disruptive critical voltage. Okay. So what it will be? I am going in short. because I have already discussed in detail what is this one video 21.1. Just check the value whenever I write the irregularity factor or the correction factor. Okay, do check those values. R radius is zero point 0.6 log 300.6. I hope it is right. Okay, now give me the answer to this value. You all have to calculate by using the calculator and give me the value. Use your calculator and give me this value. What is the value of disruptive critical voltage? Yes, correct. Sonic has told the correct value. It is comes out to be 74.40. Okay, this is kV RMS. Okay, now we have to calculate the V phase. What is V phase here? It is how much? Just a second, just a second. V phase. It will be 110 by root 3. Okay, am I correct or not? Yes. So P loss, first of all, 3 into 100 into F. F it is given here 50. So it will be 50 plus 25, 75. Divided by correction factor, it is air density correction factor. It is how much? It is just a second. Using the peak formula, the total correct is 110. Okay, this much. It is 75 by 0.96 into under root R. What is R here? Here R is zero point 0.6 divided by the spacing is 300. V phase is 110 divided by root 3 minus 74.40. Okay, whole square then into 10 raised to the power minus 5 kilowatt. Now calculate these values first of all. So 75 divided by 0.96. How much it is? 78.5. So 300 into 78.125 under root zero point 0.6 by 300 And what is this much? 110 by root 3. Calculate this value. Okay, let me calculate it. Under root 110 divided by root 3. It comes out to be 63.5 minus 74.40 whole square minus 74.440 whole, whole square. It comes out to be into 10 raised to the power. This value is 118.6. Do just confirm it from your calculator. Am I doing correct or not? Okay. This value comes out to be 0.044 into 300 into 78.125 into 10 raised to the power minus 5. Do check this, okay? The values are correct or not. All those who are present, do check these values which I just calculated is correct or not. Then we will move on towards the next step. Lucky, Sonak, Ganesh, any one of you. Okay, so it will come out to be how much? If we multiply it 122,306.25 into 10 raised to the power minus 5, and if we put this minus 5 here, it will come out to be 1.22 kilowatt. 1.22 kilowatt. Okay, so the answer will be this much. Okay, just a second. Okay, so based on this, we are have solved the various questions. Now another question here is question number 12. So what is this? This is the using Peterson's formula. Using Peterson's formula, calculate the total power loss due to corona for a three-phase 220 kV 50 hertz and 200 kilometer long transmission line. Having D equivalent is 625 R is into R, sorry, D equivalent 625, where D equivalent is the spacing between the conductors and R is the radius of the conductor in centimeter. Okay, so basically we have to calculate the value of the and assume corona loss function value f is equal to 0.05. So first of all, what is a Peterson's formula? So Peterson's formula for corona loss is PC 3 into L into 2.1 into F into V square phase divided by log D by R whole square into F into 10 raised to the power minus 5 kilowatt. F is the corona loss function. Okay. So what is PC? 3. Length is given is 200 kilometer. Okay. Into F is 50 hertz into 2.1 into what is V phase is 220 divided by root 3 whole square log what is D? It is 625 R multiplied by R whole square into corona loss function which is 0.05 into 10 raised to the power minus 5. Okay, so PC is equal to 600 into 50 into 2.1. Here R will cancel out and log 625 will be how much? We have to calculate and into 220 by root 3 whole square log 625 into 0.05 into 10 raised to the power 5 kilowatt. So based on that, so first log 625, its value comes out to be 2.795. Do check this if any mistake on the calculation part is being done. Okay, so this will comes out to be 166.33 into 0.05 10 raised to the power. So 600 into 50 into 2.1. So this will equal to 3000 into now 16133.33 divided by 2.795. It comes out to be 3000 into 5772.2 into 0.05 into 10 raised to the power minus 5. Okay, so multiplied by 3000 into 0.05 and divided by and okay, so value comes out to be 865,831.66 into 10 raised to the power minus 5 kilowatt. So we adjust it, it comes out to be 86.58. Okay, and 86.58 kilowatt. This is the power loss due to the corona losses using the Peterson's formula. So, with this, I end today's session and hope you have, you know, learned how to solve the questions and regarding the corona losses and SAG and various other. And with this, I end today's session. If you have any question, you can ask right now. Otherwise, we will meet again next week with another tutorial section. Thank you for all joining. Yes, yes.
When is the next class?
Next class, my class will be on the Sunday, 3 to 5 every day.
At what time? 3 to 5. So, what will be the next topic for the next
Next
session?
topic will be, see, these topics work in synchronization with the NPTEL lectures. Whatever those things taught over there in a theoretical way, I just solve the questions and recap of those whole things. So whatever topic we are going to be taught in a week 6, I will be covering in that week 6 lecture tutorial session. Okay.
Okay, okay. Week 6. Okay, that's fine.
Okay.
Yeah, thank you.
Thank you. And then PDF will be provided. You can see the Google Drive link. Okay. So thank you for all joining. The session ends here.